Okay, so we're going to look at matrix algebra, and we're going to kind of pull from the book and not so much from the book. The book has some things on matrices, but not everything on matrices. So we're really going to kind of jump around a little bit with matrices. First of all, this is important because it is an ACT topic, and it's something that we want to make sure that we cover, so that way you're ready for the ACT. Along with this, matrices are a really, really large part of computer programming. So we're not going to get into it in this class, but in future classes you can solve systems of equations using matrices. And I know that when you get to differential and linear equations, a lot of that class, I'd say a third of it, is can you operate with a matrix. And so matrix, we're not talking about Warner Brothers movies here. We're talking about just a way of collecting numbers and then using it to help us solve equations, usually systems of equations for the most part. And again, hugely used in computer programming. In order to get to the point, though, in the future where you could start solving systems of equations using matrices, you got to be able to do a bunch of stuff with matrices. You got to be able to add them, multiply them. You got to be able to figure out their determinant. You've got to be able to do all these different things with matrices to get there. So we're going to start with the basics. Today we're going to look at adding and subtracting matrices as well as multiplying them by a scalar. And then we'll get into multiplying matrices and then finding their determinant. So first of all, a matrix is a rectangular array of numbers that represents a multi-dimensional object. Matrices are usually used to solve linear systems as well as in vector operations. So what we have here is a 4x3 matrix. And we count it by the number of rows. So it's always the number of rows times the number of columns. I'll move that to somewhere more readable. So it's always number of rows times the number of columns. You can see here that we've got 1, 2, 3, 4 rows, and we have 1, 2, 3 columns. So we always report matrices as rows by columns. So you count up, you count down, and that gives you your number of rows. You count across, and that gives you number of columns. So we always list our matrices this way. Now, getting into matrix operations, addition is an extremely easy matrix operation. So you'll see if I add one matrix A to another matrix B, if I have got matrix A and matrix B, I just add the corresponding numbers together. Now, it's important that the matrices have to be the same size. So if I look here at my examples, so example 1, I have a 2x2 matrix. I've got 2 rows, and I've got 2 columns. So I've got a 2x2, and I have another 2x2 over here where I've got 2 rows, and I've got 2 columns. Columns in red, rows in purple. So both of these are 2x2 matrices. That's something that is important to start labeling, because when we get into multiplication, it's going to be a huge part of this. Since they're both 2x2, I can add them. So when I add these up, this is just going to be equal to 4 plus 1, 8 plus 0, 3 plus 5, and 7 plus 2. I'm just adding up the matrices and their corresponding parts. So my resulting matrix here is also going to be a 2x2 matrix. 5, 8, 8, and 9. And this is my matrix. That's the resulting matrix from adding. You just add the corresponding numbers to each other. So if you see down here, when I say perform the following operation, here I've got a 1, 2 row by 1, 2 columns. So this is a 2x2. Here I've got 1, 2 rows with 1, 2, 3 columns. So this is a 2x3 matrix. I can't add these together because they're not the same size. So I'm going to write this as undefined. I don't have a way of adding these two matrices together because I'm missing that third column in the first matrix. If they were both 2x3, then I can add them, but since one's 2x2 and one is 2x3, I cannot add them. Here, we can look again. I can say that I've got 1, 2, 3 rows by 1, 2 columns. So I'm looking at a 3 by 2 matrix. Again, 1, 2, 3 rows by 1, 2 columns. So I've got two 3 by 2 matrices. When I add these together, I've got 5 plus 2, 0 plus 4, 1 plus 0. I also have 2 plus 3, 1 plus 1, and 9 plus 2. I'm just adding the numbers together in their corresponding places, and I end up with a matrix of 7, 4, 1, 5, 2, and 11. And again, here I can see that I have a 3 by 2 matrix. So I added two 3 by 2 matrices. I ended up with a 3 by 2 matrix. That is exactly what I want to happen. This is good news for me. Subtracting matrices. Surprise, surprise. It's the exact same principle. You go through and you subtract every single value of the second one from the first one. Make sure you're paying attention to this because the order does matter. And again, just like with addition, you can only add matrices that are of the same size. So if it cannot be performed, we will write undefined. All right, so the same matrices that we had before. I'll say it again, this is a 2 by 2, and this is a 2 by 2. If I want to find B minus A, so make sure you're paying attention here because I flipped the order. This is 1 minus 4 here, 5 minus 3 here, 0 minus 8 here, and 2 minus 7 here. So I flip around that order, and then this is equal to -3, -8, -2, and -5. Again, let's make sure that we're paying attention to that order though, because that's really important. Let's say, I'm gonna reduce this size a little bit here. Let's say I wanted to do a different operation, and I'll do it in red. Let's say I wanted to do A minus B. Well, if I do A minus B, that's 4 minus 1, 8 minus 0, 3 minus 5, and 7 minus 2. When I wrote this out, I realized I made a simple math mistake. This is not -2, that's +2. All right, so now that I fixed my simple math mistake there, we can look at this and we can say that this is 3, -2, 0, and 5. Or 8, not 0. So now I'm looking at my matrix and I can see that they're all the same number, but they're opposite signs. So we end up with the same number, we end up with the same magnitude, but the signs have changed. So when I'm doing this matrix subtraction, it really does matter the order we're going in because we're not getting the same numbers. We're getting opposite numbers when we do this matrix subtraction. So make sure you pay attention to the order when you do your matrix subtraction. All right, another example of subtracting matrices. This time I just have A minus B. Again, this is a 3 by 2 matrix, and this is a 3 by 2 matrix. Each of these have 3 rows and 2 columns. So when I set up my subtraction here, I'll just do it here at the bottom. We've got 5 minus 2, 0 minus 4, 1 minus 0, 2 minus 3, 1 minus 1, and 9 minus 2. This gives us 3, -4, 1, -1, 0, and 7. So this would be the result of doing A minus B. You just go through. It's not that tough. Everything's right there for you. So pretty straightforward, pretty simple stuff. Addition and subtraction of matrices, really, really easy. When you're showing every step, it's just sometimes tedious. It can take a while to write it all out. But again, really basic concept. Multiplying matrices by scalars is also another basic concept. So here I've got an example. We're saying we're multiplying A by some random value, lambda. And that lambda is just representing any value. And I've got an matrice here. It's just represented by all the different possible matrices that you could have. If you multiply a matrix by a number, that means you multiply every single number in the matrix by that same value. So this is what we call multiplying by a scalar because we're just multiplying by one number. And when I multiply these matrices by a scalar, so we've got an example here. Let's find 3b. So 3b is 3 times 1, 5, 0, and 2. That means my new matrice will be 3 times 1, 3 times 5, 3 times 0, and then 3 times 2. So then my final new matrice here would be 3, 15, 0, and 6. So I've multiplied every single value in that matrix by 3. When I do 5a, same principle. I'm going to skip ahead to just saying that this is going to be 5 times 4. Let me change colors here so that way we can differentiate this a little bit better. 5 times 3, 5 times 8, and then 5 times 7. So this will be 20, 40, 15, and 35. So that will be our new matrix. And then when we add these two together, again, we just add both of these are 2 by 2. We've been working with these matrices. When we multiplied by scalars, we ended up with 2 by 2. So when I'm adding these together, we just end up with 3 plus 20, 0 plus 40, 15 plus 15, and 6 plus 35. So this is 23, this is 40, this is 30, and this is 41. So these are how we would go about doing these, of how we would find multiplying by a scalar, and then sometimes you'll multiply those scalars and then combine matrices after multiplying by the scalar. But it's still like order of operations. We're still going to multiply those scalars first before we start doing addition. So it's still PEMDAS, we still have multiplication first, and then we do our addition. All right, you guys have a homework. It's 2 things. There are some problems out of the book as well as a worksheet on Google Classroom. So you have a worksheet and some book problems to work on both. And both those answer keys are there. If you have any questions, please reach out. I'll make sure to go over this in class as well. But have a great night.